All right, so this is the lecture on the solid principles, why software design matters, and why we do what we do in software design. So, first of all, for the solid principles, the S is the single responsibility principle, the O is the open close principle, L being the Liskov substitution principle, I being the interface segregation principle, and D being the dependency inversion principle. So first, the single responsibility principle. Classes should only have one responsibility and one reason to change. Basically, what this means is we have super simple and focused classes that allow us to make code easier to read, maintain, and scale. It also reduces weird things with classes being very, very complex. To obtain this, we make classes more concise with more focused responsibilities, which often involves dividing current classes into several other classes. For example, a subsystem class should focus only on one part of the robot, divided into several more subsystems if absolutely necessary. So, for an example for S, if we have a simple decode FTC robot, could be systemized like this. So bad single responsibility principles design would use subsystems like the drivetrain and the shooter, where it's pretty. I mean, it's pretty simple, but we could change it into being feeder, where our feeder takes care of our two servos right here and the one on the other side, and our shooter right here would take care of this motor. And then the drivetrain, of course, would take care of our overarching drivetrain. So this would make each subsystem focused on its exact purpose and be very intentional with the design of the subsystem. The open-close principle defines that classes should be open for extension, but closed for modification, essentially treating code libraries as a source of truth, however being able to extend and add to those classes. For this, there's not many examples for robotics, but it's important for making modular code in libraries, which we might be doing. So for the Liskov substitution principle, objects of a superclass should be able to be replaced with objects of a subclass without affecting how the program works. So basically, in this way, subclasses behave very similarly to their parent class. And this is not nearly as important for FTC as we have little to do with subclasses and inheritance. So then for the interface segregation principle, a client should not be forced to depend on interfaces that it does not use. Basically, like if you're making a coffee machine, right? A coffee machine class. Well, you don't want this coffee machine to also force the user to go get coffee beans themselves and harvest it from trees themselves. Obviously, that's another part of the process. So specific interfaces and classes fall under this principle, and it reduces the complexity of your overall code. For a specific example, if you're only using rev motors, you should not be expected to also implement code for Go build specific motors. And this is much more important from an interface in a library point of view. So then moving on to the dependency inversion principle, high-level modules should not depend on low-level modules. Essentially, if you make a class, it should not be forced to depend on singular other low-level dependencies to make it usable for many different dependencies. So in this way, basically, don't implement low-level things and make them depend up to that high level. For instance, like if you're building a class inside of a library, that should not rely on anything like the Roadrunner library or the Pedro pathing library to where it can't run without it, because then people have to implement that other subset of things. So then why any of this matters, the solid principles make sure your code is modular, maintainable, easy to read, and simple. It helps reduce long debug sessions. It's important a lot in library code design, and it helps the future generations to read the code. So that's it. That's all the solid principles. Thank you for watching.